rational functions, graphs, and applications and models. So let's talk about the first one here, graphing this particular function that was given to us. Let me get my mouse over here. All right, so we have this y equals negative 2 over x. So in order to graph this, we're going to need to come over here and make us an xy table. And since it's equal to y, I can start plugging in points for x. So let's go small. Let's do what? 1. And so plug in 1. When I get that, what I get negative 2, because I'm putting in y equals 2 over 1, right? Negative 2 over 1 was just negative 2. So if I put in 2 for x, then I get 2 here, and I get negative 1. Okay, so I got 2 order pairs already. So let's plot that. So I go here to 1, go down to negative 2, and then I go to 2, and it takes me down to negative 1. Okay, so I got 2 order pairs. Let's do one more order pair. Let's plug in 4. When I plug in 4, this here becomes a negative half. All right, so now I'm going to go where 4 is at here, and we're going to go just halfway. So now I'm going to connect the dots, and I get this kind of function going on. Whoops. Let's see if I can get the dots connect. So I get this kind of function going on. Okay. Well, we need to solve for the other side of the function. All right. So what I'm going to do is I'm going to plug in for x and y. And let's go bigger. Let's go on the other side of this origin here. So let's say, what if I pick negative 10? Then I get y is equal to negative 2 over 10. And we're going to put negative. It gives me what? A positive 1/5. Okay. So if you're not sure where that is, we can divide it. So it's 0.2, right? So we're going to go out to negative 10.2 right here somewhere. A little more on the line. And then I'm going to put in, let's put in negative 4. That gives me a half. So at negative 4, 1, 2, 3, 4, go down to the right here. Let's pick negative 2 because I'm getting closer to 0. When I do that, I get what? A positive 1. So at negative 2, I get positive 1. So now we got this function going like this. Oops. Try to connect the dots better. So now let's state the domain and range. Well, my domain and range, if you look at it, these arrows here tells me that it's going from what? Negative infinity off to 0, you know, because it's split by this line, this x and y line, negative infinity off to 0. And then it goes all the way up to positive infinity. So my domain and range is negative infinity to 0. And it's going to union 0 to positive infinity because the arrow says that it's going to keep going on. Okay, so let's do the next example. The next examples were given 2 divided by x plus 1. So what we can do is determine its domain and range. And the reason why, let me come up here and explain this right quick. I missed out on it. The reason I knew that we weren't going to cross the y-axis is because we have to look at what's the domain of the fraction. Oops. Remember that whenever we solve for a domain, it's our restriction. So if I put 0 in for x here, we get an undefined function. So therefore, it doesn't cross this y-axis because it'll cause it to go to 0 and be undefined. So looking at this one here, we're going to start off right off the bat. We're going to take the x plus 1 and we're going to set it not equal to 0 and solve. So it said x cannot equal negative 1 because I got to subtract the 1 from both sides. So it cannot equal negative 1. So that means its domain is going to fall where it's going to be restricted at -1. Let's draw it and to make sure where exactly it's at. Where up here, the domain and range was the same because if you notice, both directions, the arrows were going off to negative infinity on the side, up to positive infinity, negative infinity to positive infinity. So the domain and range didn't cross the 0 axis or the y axis, causing x to be 0. Okay, so I'm going to create an XY table right here. And let's start solving. So if I plug in 1 and I plug in 1 for x, then I get 2/2, which is 1. If I plug in 3, I get 2/4, which is 1/2. If I plug in 0, I get 2/1, which is just 2. So there's 3 points. So let's go plot those right quick. So I got 1, 1. I got 3.5 right here. And then I got 0, 2. So I know that I got something like this, which makes sense because it's not going to cross this line right here. It's not going to cross when x is -1. It'll get close to it, but it won't cross it. All right. My drawing's a little off there. All right, so now let's find what happens on the other side of that -1, right? This is on this side of it, x equals -1. And now let's look on this side of x equals -1. So I got my XY table. So I'm going to plug in, let's plug in -3. So the -3 plus 1 gives me 2/2. So it gives me -1. Let's plug in, we can plug in -9, right? I plug in -9, it gives me -8. 2/8 is a -1/4. So let's do one more. Let's do -10. If I plug in -10, I get what? -9, 2/9, which is what? -2/11. So if y'all need to plug it in and write it on the side, I would encourage it. All right, so let's go plot it. So I got -3, 1, 2, 3, -1. -9, and -1/4. And -10, and it's getting really close to that line there. So connect the dots and we get something like this. It gets close to the -1. So now let's determine what's my domain and range. Well, my domain we know is negative infinity because the arrows to -1, and it unions at -1 to infinity, where my range goes negative infinity to 0, and it unions 0 to infinity. It's because it didn't. Yeah, my range is my y-axis, so it would give me 0 if we cross that point on the x-axis. Because look, it's not crossing right here, the x-axis. See it? It didn't cross the x-axis. Up here, it crossed it. All right, so now our next example we want to work. Let me get my mouse going. So what we're going to do is we're going to rational the function of f, and we're going to find its asymptotes. So first things first, let's find the vertical asymptote. And then the directions and all the information on the definitions of these are in our course materials. So I'm going to find the vertical asymptote. Okay, well, to do that, we have to look at the denominator. Okay, so what I'm going to do is take each part and set it equal to 0. And solve. We want to do that at 1. I get 2x equals 1 divided by 2. X equals 1/2. Let's subtract the 3. Now I get x equals -3. Okay, so my vertical asymptote is at x equals 1/2 and -3. So if I was to put it on a graph, this function will not cross those points. I would literally, let me see if I got, let me get a graph. So at x equals a half and x equals -3, let's do this right quick. Let's go under here. Make it a little neater. Okay, so x equals a half. It's gonna be hard to draw. You would draw a dotted line, it would be a lot straighter than what I'm doing here. I'm saying that that function wouldn't cross here and it wouldn't cross at -3. So we'd have, so if we look at it, we got something going on this side, in the middle, and on this side. So we'd have to find out what's going on all around it in order to graph this. This vertical isotope tells me that my function will not cross those points when x equals that, because if it did, then it would be an undefined function. So now let's find the horizontal isotope. Okay, so when we do that, we have this definition that x, the numerator, the x in the numerator, so I put an n on its power over the x in the denominator, I'm gonna put an m on it. Okay, the rule says that if the power, which I'm gonna call it n, is less than the power in the denominator, then my isotope is gonna be 0, my horizontal one. It says if my n is greater than m, then we have an oblique isotope. If my n is equal to my m, then what we're going to do is we're going to take the f of x and the coefficient on that x, and we're going to call it a, over my coefficient, and we're going to call it b on the denominator. We're going to take it, and that's what's going to be our horizontal isotope. So let's look at this one. In order to know that, I need to full this out. So I got x times x. We know it's going to be 2x squared. So this tells me the numerator power is greater than the denominator power. Oh, no, excuse me. I said that backwards. Is less than, yeah, because the power in the numerator is 1. See it? And then power in the denominator is 2. So since it's less than, then we know the horizontal isotope is 0. So where y equals 0 is right here on the x-axis. So we put our line there. Now the function can cross the y-axis or the horizontal isotope. It can, but the verticals it will not, because it causes the function to be undefined. Okay. So let's see what another example we have. We have a couple more. Yes. Let me go grab another graph, or we'll pass on the graph just for a moment. Let's talk about it. The vertical isotope again. Vertical isotope, I'm just going to say v dot a. We take the denominator, set it equal to 0, and solve. So we know the vertical isotope is x is equal to 3. The horizontal, let's go ahead and just initiate as HA. We're going to determine, and when we look at the power in the numerator is 1, the power in the denominator is 1, so that means they are equal. If they're equal, then that means we take the coefficient on x, which is 2 over 1. So it's 2. So my horizontal isotope is y equals 2. Okay. Now let's do our last one. All right. So again, let's find the vertical isotope. When we find it, we look at the denominator, set it equal to 0, solve. That gives me my vertical isotope. My horizontal isotope, we look at the power in the numerator, and it's greater than the power in the denominator. So this means it's an oblique isotope. All right. Now, to figure out what is the oblique isotope, we're going to use long division. Remember, the denominator goes on the outside. So long division says x times what will equal x squared. We know it's x. So I'm going to put it right here. And if you notice, I'm going to do a little space here. We are missing the x to the first power. So I'm going to put plus 0x plus that 1. So that would go here. So x times x is x squared. X times negative 2 is negative 2x. We're going to subtract. That means this becomes plus because negative times that. So now I got 2x and bring down the plus 1. So x times what gives me 2x? It's a positive 2x, or excuse me, a positive 2. So 2 times x is 2x. 2 times the negative 2. Change it to the subtraction. And now we got 3. So my oblique asymptote will be y is equal to x plus 2. And you'd use that formula of mx plus b, you know, the slope-intercept form to graph it. And that is solving for our asymptotes.